So what if I told you that one of the biggest leaps in AI reasoning didn't come from some new supercomputer, but from a trick so simple your grade school teacher probably told you to do it every single day? Today, we're going to dive into the absolute magic of something called chain of thought prompting.
Okay, let's start with a really simple question. A cafeteria has 23 apples, they use 20, and then they buy 6 more. How many do they have left? Pretty easy, right? You've probably already got the answer in your head. It's a basic multi-step problem that a kid could solve.
And you're right, of course, the answer is 9. But just look at what happened when a really powerful AI was given this exact problem. On the left, using what we call standard prompting, it just blurts out 27. I mean, totally wrong. But now look at the right. It's the same AI, but with a different kind of prompt. Here, it lays out its logic. Okay, 23 minus 20 is 3, then 3 plus 6 is 9, and boom, it gets it perfectly right. So what on earth is going on here? How does just showing your work make an AI so much smarter?
Well, to understand that, we first need to look at a surprising weakness that's kind of hidden inside these incredibly powerful models.
You have to remember, a large language model is basically an incredible pattern matcher. It's a prediction engine. So when you give it a standard prompt, its instinct is to predict the final answer in one single jump. For a problem with multiple steps, that's like trying to solve a maze by just teleporting straight to where you think the exit is. More often than not, you're going to end up in the wrong place.
So the challenge wasn't to make the AI more powerful, but to teach it a better process, to get it to actually navigate the maze step by step instead of just trying to jump to the end.
And the solution, the big idea that really changed everything, is a concept we all learned back in school. It's literally just about telling the AI to show your work.
This method is officially called chain of thought prompting. The idea is you don't just ask for the final answer. Instead, you give the model a few examples where you've already laid out a logical, step-by-step reasoning process. You're basically demonstrating how to think through a problem, not just what the solution looks like. For example, let's take this classic Rogers tennis balls problem from the research paper. Instead of just spitting out 11, the chain of thought model breaks it all down. Step 1, identify the starting number. Okay, 5. Step 2, calculate the new balls. Right, that's 6. Step 3, do the final addition. Each step is a small, manageable calculation that guides the model reliably to the correct answer.
So what this approach does is 3 really powerful things. First, it forces the model to break down big problems into smaller, easier ones. Second, it gives us a transparent, interpretable window into how the model got its answer. And because of that, if the model gets something wrong, we can actually go back and debug its reasoning path to see where it went off the rails. And this simple little change didn't just help a little bit. It led to an absolutely staggering leap in performance. But here's a fascinating little twist from the research. This ability to reason in a chain of thought, well, it isn't something all AIs can do. It's what's called an emergent ability. It only seems to appear in truly massive models. We're talking over 100 billion parameters. That's 100,000 million. For smaller models, this technique can actually make things worse. It's a skill that only unlocks at a truly colossal scale.
And this chart right here is the money shot. This shows Google's 540 billion parameter PaLM model trying to solve a bunch of really hard math word problems. With a standard prompt, it gets a pretty dismal 18% correct. But with chain of thought prompting, its scores skyrockets to 57%. That's more than a 3 times improvement, setting a new state-of-the-art result just by changing the prompt. And this wasn't just a one-trick pony for doing arithmetic. No. This simple technique unlocked brand new capabilities across a whole spectrum of complex reasoning tasks.
I mean, all of a sudden it could handle common sense reasoning, like figuring out that a pear would float based on its density. It could master complex date understanding. It could perform symbolic reasoning, like taking the last letters of Lady Gaga to get ya. And it could even do state tracking, like figuring out if a coin is heads up or tails up after a series of flips. These were all things models really struggled with before this.
Okay, so let's wrap this up. What are the big takeaways from this discovery, and what does it all mean for the future of AI?
This is, without a doubt, a huge step forward for creating AI that's not just more capable, but also more reliable and easier to understand. But, and this is important, the researchers are very clear that it is not a perfect solution. It's not a silver bullet.
There are a few key limitations to remember. First, this only works on those massive, really expensive models. Second, just because the AI shows its work, that work isn't guaranteed to be factually correct. It can still make stuff up. And finally, the model can sometimes follow a totally flawed path of logic and to stumble upon the right answer by coincidence. So the reasoning gives us insight, but you still have to verify it.
So, to be really clear, chain of thought doesn't prove that an AI is truly thinking or reasoning like a human does. But it is a monumental step towards building AI systems that are more transparent, more debuggable, and ultimately more trustworthy. It's a huge shift from just getting an answer to understanding the journey to that answer.
And all this leaves us with one last kind of provocative thought. As these models get better and better at explaining their own internal logic and mimicking the very processes that we use, where do we draw the line? If an AI can not only give you the right answer, but also show its work and explain exactly how it got there, is it actually thinking? Something to think about.